Have you ever thought about finding a perfect Earth 2.0? You know, a shimmering blue marble out there in the cosmos. But what if that paradise was actually a perfect trap? Yeah. Let's get into the fascinating and frankly dangerous case of the exoplanet Kepler 22b. Okay, first things first. This potential second Earth, it is not exactly next door. We're talking 635 light years. And just to put that into perspective for you, even if we had some futuristic spacecraft that could travel at, say, 20% the speed of light, it would still take over 3,000 years to get there. So yeah, it's seriously far away. So you might be asking, why all the excitement then? Well, here's the hook. Scientists think Kepler 22b could be a true water world. I mean, a planet almost completely covered by a huge liquid ocean. And you know what they say? Where there's liquid water, there's that tantalizing possibility of life. All right, so to really get our heads around Kepler 22b, we need to start with the basics. You know, what even is it? It's something astronomers call an exoplanet. And that's where we'll start.
It's actually a pretty simple idea, but when you think about it, it's profound. Our solar system, it's just one tiny little neighborhood in this huge cosmic city. So exoplanets are just all the other planets orbiting the billions, literally billions, of other stars out there. And Kepler 22b, it's one of the most intriguing neighbors we've found so far, for sure.
Okay, so let's zoom in a bit. Let's take a look at this specific cosmic neighborhood. What kind of star does this potential water world even call home? And here's what's so incredible. This system looks, well, it looks really familiar. It seems to have just this one known planet, and its star, it's a G-type star. That's just like our own sun. It even has a very similar temperature. I mean, on paper, this is the absolute perfect setup for an Earth-like world. But, you know, the star is really only half the story. The most crucial factor for Kepler 22b's potential for life, it all comes down to one thing. You've heard it before, location, location, location. And this right here is the key concept. It's called the habitable zone, but you've probably heard it called the Goldilocks zone, right? It's that perfect orbital distance from a star. Not too hot, not too cold, but just right for liquid water to exist on a planet's surface. And guess what? Kepler 22b orbits squarely within this zone. You know, looking at planets we're familiar with really puts this into perspective. If you get too close to the star, like Venus, any water just boils away. Go too far out, like Mars, and it freezes solid. But Kepler 22b, it's sitting right there with Earth, in that perfect sweet spot where water can stay liquid. Okay, so let's recap. We've got a planet, it's got a sun-like star, and it's in the perfect location for liquid water. So, it's Earth 2.0, case closed, right? Well, not so fast. This is where the story takes a pretty sharp turn. This isn't an Earth twin. It's what scientists call a super-Earth. And the differences, they are dramatic. Look at this. Kepler 22b is more than twice the size of Earth and over 9 times as massive. Now, think about what that means. That translates to a surface gravity that's more than double what we're used to. Just walking around on this planet would feel like you were carrying another person on your back 24/7. So this supersize has some massive implications, and it really all comes down to one thing, the atmosphere. See, a planet this big has some serious gravitational muscle, enough to hold on to a very, very thick atmosphere. And that atmosphere could be the secret to either a paradise or a total inferno. So let's explore that for a second. This is a critical question because a thick atmosphere could lead to 2 wildly different outcomes. Okay, so on the one hand, a thick atmosphere could act like a perfect global blanket, you know? It could keep the planet at this really comfortable 22 degrees Celsius or 72 Fahrenheit. Sounds amazing. But on the other hand, that exact same blanket could trap way too much heat. It could trigger a runaway greenhouse effect, basically turning the entire planet into a scorching hot, high-pressure version of Venus. 2 totally different worlds. But, okay, what about the other possibility? Now, it's probably less likely for a planet this massive, but what if, for some reason, it couldn't hold on to its atmosphere? Well, without that atmospheric blanket to trap heat, the planet would be a lot like Mercury. It would be absolutely baked during the day and then flash frozen at night. So clearly, the presence and the nature of its atmosphere makes all the difference in the world. Okay, so this brings us to the final critical question. We've looked at all the evidence, right? The location, the size, the potential atmosphere. So, what's the verdict? Let's just assume the best-case scenario here. We've got a beautiful 72-degree water world. You manage to land your ship, you open the door. Could a person actually stand on the surface? Could you survive? The answer to that question, unfortunately, lies in a pretty terrifying medical term, barotrauma. And it's what happens to the human body when it's subjected to extreme changes in pressure. And that is the killer twist. Because Kepler 22b is just so massive, its atmosphere, if it has one, would be incredibly dense. We're talking crushing. The moment you stepped outside, the immense pressure would instantly, catastrophically, crush the air right out of your lungs. They would just collapse. And this brings us to the most important takeaway from this whole thing. It's the difference between two simple-sounding words. Habitable, that's an astronomical term. It just means a planet has the right ingredients for life, like liquid water. But inhabitable, that's what matters to us. It means, can we humans actually live there? And Kepler 22b is a perfect, chilling example of a world that is very likely one, but absolutely not the other. And that really leaves us with a final kinda chilling thought, doesn't it? As we find more and more of these so-called habitable exoplanets all across the galaxy, we have to ask ourselves, how many of them are true second Earths? And how many are just beautiful, deadly traps waiting for us out there in the stars?